According to the National Electrical Code, or NEC, anti-short bushings are not required for medium voltage cable or M/C in all cases. Article 334.40. It 1 states that for raceways exposed to different electrical potentials or when installed on opposite sides of a partition or wall, M/C with or without an anti-short bushing may be used within a metallic cabinet or enclosure. Article 334.40. A2 states that for raceways exposed only to the same electrical potentials, M/C with an anti-short bushing is not required. Anti-short bushings are required in the following situations. Firstly, when M/C is installed between separate electrical enclosures with different electrical potentials, and secondly, when M/C is installed on opposite sides of a partition or wall, for example, into different rooms. The purpose of anti-short bushings is to provide an insulating barrier between the M/C armor and the termination fitting. This prevents electrical shorts between the armor and the fitting, which can occur when the fitting is tightened to the armor. The requirement for anti-short bushings is influenced by, firstly, voltage level, where anti-short bushings are more critical for higher voltage applications. Secondly, conductors within the M/C, where if the M/C contains multiple insulated conductors, there is a higher risk of shorts between them, making anti-short bushings more necessary. And thirdly, fitting design, where some fittings are designed to require anti-short bushings, while others do not. Whether or not anti-short bushings are required for M/C depends on the specific installation conditions and the fittings used. It is important to follow the NEC requirements and the manufacturer's instructions for the particular fitting being used. Let's delve into the specifics of when anti-short bushings are necessary for M/C cable installations according to the NEC. The primary function of an anti-short bushing is to prevent the sharp edges of the cut M/C armor from damaging the conductors inside, potentially causing a short circuit. The NEC provides guidelines on when these bushings are mandatory to ensure electrical safety and compliance. Article 334.40 outlines the requirements for using anti-short bushings with M/C cable. The key factor is whether the M/C cable is exposed to different electrical potentials or installed on opposite sides of a partition or wall. When M/C cable runs between enclosures with different electrical potentials, such as separate electrical systems or equipment operating at different voltage levels, anti-short bushings are required. This is because any fault in the cable could create a dangerous short circuit between the systems. Similarly, when M/C cable passes through a wall or partition, especially into different rooms or areas with different electrical systems, anti-short bushings are also necessary. This prevents potential shorts if the cable insulation is damaged. In situations where the M/C cable is exposed only to the same electrical potential, the NEC does not mandate the use of anti-short bushings. This typically applies to installations within a single electrical enclosure or when the cable runs continuously through an area with a uniform electrical system. However, it is crucial to consider the specific fitting design and manufacturer's instructions. Some fittings are designed to require anti-short bushings regardless of the electrical potential. Always refer to the fittings documentation to ensure compliance. The absence of anti-short bushings where required can lead to several risks. Firstly, the sharp edges of the M/C armor can cut into the conductor insulation over time, causing a short circuit. Secondly, a short circuit can result in overheating, arcing, and potentially a fire. Thirdly, non-compliance with NEC regulations can lead to fines and legal issues. In addition to the NEC requirements, several factors influence the decision to use anti-short bushings. The voltage level of the system is a primary consideration. Higher voltage systems pose a greater risk of electrical shorts, making anti-short bushings more critical. The number of conductors within the M/C cable also matters. Cables with multiple insulated conductors have a higher risk of shorts if the insulation is compromised, necessitating the use of bushings. Furthermore, the design of the fitting itself plays a significant role. Some fittings are specifically designed to require anti-short bushings, while others provide sufficient insulation and protection without them. To ensure compliance and safety, always follow the NEC guidelines, consult the manufacturer's instructions for the specific fittings being used, and consider the voltage level and conductor configuration of the M/C cable. In summary, anti-short bushings are essential for preventing electrical shorts and ensuring safety when M/C cable is installed between enclosures with different electrical potentials or through walls and partitions. While they may not be required in all situations, careful consideration of the installation conditions, fitting design, and applicable codes is crucial for every M/C cable installation. Now let's explore the practical aspects of installing M/C cable with and without anti-short bushings, ensuring both safety and compliance with the NEC. Before starting any electrical work, always ensure that the power is turned off to the circuit you will be working on. Verify the absence of voltage using a reliable voltage tester. This is a critical safety step that should never be skipped. When working with M/C cable, begin by carefully cutting the cable to the desired length using an appropriate cable cutter. Avoid using tools that can damage the insulation of the conductors inside. Once the cable is cut, prepare the end for termination by removing the outer jacket and exposing the conductors. Use a cable ripper or knife to carefully slit the jacket without damaging the conductors. With the conductors exposed, slide the M/C fitting onto the cable. If the fitting requires an anti-short bushing, insert the bushing between the armor and the conductors. Ensure that the bushing is properly seated and provides a complete insulating barrier. Tighten the fitting securely onto the M/C cable, following the manufacturer's instructions. Over-tightening can damage the cable or fitting, while under-tightening can result in a loose connection. If the fitting does not require an anti-short bushing, ensure that the fitting is designed to provide adequate protection against the sharp edges of the armor. Some fittings have built-in insulating features that eliminate the need for a separate bushing. When installing M/C cable through walls or partitions, use appropriate mounting hardware to secure the cable. This prevents strain on the cable and fittings, reducing the risk of damage. If the cable is exposed to physical damage, consider using a conduit to provide additional protection. After completing the installation, inspect the connections to ensure that they are secure and that all components are properly installed. Use a torque screwdriver to verify that the fittings are tightened to the correct torque specification. Finally, test the circuit to ensure that it is functioning properly and that there are no short circuits or ground faults. Use a multimeter or circuit tester to verify the integrity of the wiring. When working with high voltage systems, it is especially important to follow all safety precautions and to use appropriate personal protective equipment, or PPE, such as gloves and eye protection. In situations where anti-short bushings are not required by the NEC, it is still a good practice to use them as an added layer of protection. They are inexpensive and can prevent potential problems down the road. Always consult with a qualified electrician if you are unsure about any aspect of the M/C cable installation. They can provide guidance and ensure that the work is done safely and in compliance with all applicable codes and regulations. Remember that electrical work can be dangerous, and it is important to take all necessary precautions to protect yourself and others. Proper planning, careful execution, and attention to detail are essential for a safe and successful M/C cable installation. By following these guidelines and staying informed about the latest NEC requirements, you can ensure that your electrical installations are safe, reliable, and compliant. Let's consider some real-world examples of M/C cable installations and the application of anti-short bushing requirements. Imagine a scenario where you are installing M/C cable in a commercial building to supply power to lighting fixtures. The cable runs from a panel board in one room, through a wall, and into another room where the fixtures are located. In this case, anti-short bushings would be required because the cable is passing through a wall separating two different rooms. This is to prevent potential shorts if the cable insulation is damaged as it passes through the wall. Now, consider another scenario where you are installing M/C cable within a single electrical enclosure to connect various components. The enclosure is properly grounded and all components operate at the same voltage potential. In this situation, anti-short bushings may not be required, provided that the fittings used are designed to protect the cable from the sharp edges of the armor. However, it is always a good practice to check the manufacturer's instructions for the fittings to ensure compliance. In a residential setting, you might be installing M/C cable to supply power to an appliance such as a refrigerator. The cable runs from a circuit breaker in the main panel to an outlet near the refrigerator. If the cable is installed within the same room and the fittings used provide adequate protection, anti-short bushings may not be necessary. However, if the cable passes through a wall into another room, anti-short bushings would be required. Another example involves installing M/C cable in an industrial facility to supply power to machinery. The cable runs from a motor control center to a motor located in a different part of the plant. In this case, anti-short bushings are highly recommended, especially if the cable is exposed to physical damage or harsh environmental conditions. The bushings provide an extra layer of protection against shorts and ensure the reliability of the electrical system. When working on a construction site, you might encounter situations where M/C cable is used to supply temporary power to various tools and equipment. In these cases, it is important to use anti-short bushings to protect the cable from damage and to prevent potential hazards. The bushings are especially important if the cable is frequently moved or subjected to rough handling. Consider a situation where you're upgrading the electrical system in an older building. The existing wiring is outdated and needs to be replaced with new M/C cable. As you remove the old wiring, you discover that the original installation did not include anti-short bushings. In this case, it is essential to install anti-short bushings with the new M/C cable to bring the installation up to code and to ensure the safety of the electrical system. When installing M/C cable in a data center, you need to be especially careful to protect the cable from damage and to prevent potential shorts. The high density of electrical equipment in a data center makes it particularly important to use anti-short bushings to ensure the reliability of the power supply. In a healthcare facility, the electrical system is critical for supporting life-saving equipment. It is essential to use anti-short bushings when installing M/C cable to ensure the reliability of the power supply and to prevent any potential disruptions. When working on a solar power installation, you might be installing M/C cable to connect the solar panels to the inverter. In this case, it is important to use anti-short bushings to protect the cable from damage and to ensure the efficient operation of the solar power system. These real-world examples illustrate the importance of understanding the NEC requirements for anti-short bushings and of applying them appropriately in different installation scenarios. By following the code and using good workmanship practices, you can ensure that your M/C cable installations are safe, reliable, and compliant.